One more example of being able to use the 8-bit addition, we have -15 plus -46 to be able to add two numbers. And hopefully you work through this on your own just to verify that you're able to do it. But if not, or if you were unable to, let's see how to do this. So we're going to start out with our sign bit. And just like we've done the other two times, we have our 2 to the 6, 2 to the 5th, 2 to the 4th, 2 to the 3rd, 2 to the 2nd, 2 to the 1st, 2 to the 0. And at this point, what we're going to do is we're going to convert the numbers of 15 and 46 over. And remember, the sign bit starts as 0. Now, we know that neither of the values have a 64 in it, but we know that 46 is 32 plus 14. So, let's just work through this one. So we took out the 32 and we have 14. So we don't need a 16, but to get 14, we need 8 and 4 and 2. All right. 15 is really easy because there is no 64, there's no 32, there's no 16, but then 15 minus 8 is 7, 7 minus 4 is 3, 3 minus 2 is 1, and then here, right? Now, unfortunately, we need the 2's complement of both because both started out with a negative, all right? So let's just take the 2's complement of both of these, all right? So now we get -15 and -46, all right? And when we get that, that's going to be 0, 0, I'm sorry, 1, 1, 1, 1, 0, 0, 0, 0. So we're just flipping all of these bits in this row. So that's 1, 1, 1, 1, 0, 0, 0, 0. And now we're going to flip all the bits for 46, which is going to be 0, or sorry, 1, 1, 0, 1. And then 0, 0, 0, 1. Right? But remember at the end, we have to add a 1 to both. Right? So to get the 2's complement, we have to add a 1. And so what does that mean? So right here, that's easy because 0 plus 1 is 1. But right here, we have a carry because 1 plus 1 is 2. So right here, we're just going to erase these two, and that's our 10. We're going to add these two numbers together. Right? So 0 plus 1 is 1, 0 plus 1 is 1, 0 plus 0 is 0, 0 plus 0 is 0, 1 plus 1 is 2, or 10. 1 plus 1 is going to be 10. 1 plus 1 plus 1 is 11. 1 plus 1 plus 1 is 11. And then we have this overflow. Right? So we're going to cut that off. Right? And that just says that anytime we have anything past the 2 to the 8th spot or anything past the sign bit, we just truncate it. Right? So, and you might be thinking, well, this isn't going to work, but let's see if it does work. Now, notice the sign bit. So anytime after you're done adding, sign bit equals 1, that means we need to take the 2's complement. And the 2's complement's pretty easy for this one. It's going to be 0, 0, 1, 1, 1, 1, 0, 0. And then we have to add the 1 at the end. And so our 2's complement, and remember this number is now negative, -0, 0, 1, 1, 1, 1, code 1. And what does that look like in decimal? Because that's what the computer would do, is it would say, okay, well, now that I see it's in binary and the negative's out front, the final thing I would do is I would print the negative and then print convert it out. Right? So this is 1, and this is 4, 8, 16, 32. All right, so if we add these together, 32 and 8 is 40, 40 and 20 is 16, or I'm sorry, is 60, and then should be -61 in base 10. And the question is, does that make any sense? Well, we go back up here, and we know that 15 and 46 is 61. So it does make sense. All right, so that's the end of this section. Key takeaways from this entire section: make sure you can convert back and forth between a Boolean circuit, an input-output table, and then also make sure you can write the Boolean expression for that. Make sure you can convert back and forth between decimal, hexadecimal, as well as binary. And then finally, make sure that you can go through and do this 8-bit addition.